My name is Yashis, correspondent for First Updates Now, and with me today are Team 18813, the FullMetal Phoenixes from Connecticut, who put up a great performance today here at the CT State Championship, coming in the finalists and Alliance first pick. Come with me more on First Updates Now as we go through a Behind the Bot.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
So to start off with your robot, let's just talk about your drivetrain. What were What was your thoughts behind making the mechanism drivetrain how it is, and what speed is it running at, so forth?
Reliability, maneuverability, and with defense becoming more of a factor this season, we wanted a robust build. You can see we have a fairly large drivetrain. We're running 4 mechanism wheels with all-wheel drive for maximum speed, good strafing, and good maneuverability. That's especially helpful getting things on the backdrop. It creates an incredibly easy effect. We have, a great range of motion, which lets us very easily take control of the field. As far as speed, I think we're at 1360.
No, 11. For our drivetrain motors, we use 312s.
So how does your intake system work? How are you picking up the pixels when it comes to match play?
Phoenix tradition, we went with a claw. We started out with, we had a lot of different designs. After like 3 iterations, we ended up with this. We have a 3D printed backdrop to help us get things on the backdrop. Essentially what happens is the pixel that's the furthest out, arm goes back, this gets dropped directly onto the backdrop. The second one gets caught on this lever here. We can release it secondarily to prevent interference between the two. This part drops down, this slides right on, good to go.
Yeah, that's a great innovation to make sure that both pixels will fall on the backdrop evenly and you can control them one at a time. So for your outtake, I'm assuming it's the same method you described for your intake?
Exact same system.
Great. And then what about your drone and your hang system? How do those work?
Hang system is right here, this little notch here. We use actuated, our 3-joint arm has linear actuators, which allows us to extend up this final arm, which we can then rotate around the hook and then pull that linear actuator in, lifts us right off the ground reliably every time. Especially given the weight of our bot, those linear actuators are necessary to pull it up smoothly every time. As far as the drone system goes, we got a simple slingshot using a torque servo to hold it in place. The torque servo is necessary because we've seen a lot of teams after autonomous, when their code cuts out, a lot of their servos give out, causing an unnecessary launch. Torque servo helps resist the motion of this rubber band, which prevents said launch. Without the torque servo, we wouldn't be able to lift this up to resist the force of that rubber band, which keeps us from doing that aforementioned unnecessary, unplanned launch.
Yeah, that's amazing. So moving on, I want to talk more about that 3-motion arm that you talked about. So can you explain more how that works?
Sure. 3-joint arm, it's affixed to the drivetrain right here, these joints right here, affixed directly to the drivetrain. This first part of the arm, this first joint is lifted up by this crankshaft looking device right here. We've got high-speed motors inside that push it right up. Again, we need strong motors to do this because our bot is fairly heavy. Second point of rotation is right here, driven by this, what's the gear called? These worm gears back here. Again, necessary to hold up the weight. And we need a lot of torque to do it, so here you get them. Those worm gears right there, and yeah, just this one. That's right here. Goes through, drives this axle, lifts this arm up. Last point of rotation is this servo right here, which allows us to adjust the wrist to create better precision when actually dropping onto the backdrop.
Yeah, that's amazing. So that's about it for your robot. So I just want to move into the software. This is a very impressive and very unique and innovative robot, and it's pretty complex. So how do you go about coding this and making sure that everything performs as expected during the match?
So for teleop, it's pretty straightforward. We just have the driver, and the driver just controls the drivetrain, obviously, with the mechanism wheels, just standard mechanism wheel drive. They also control the claw because we feel like it's easier for them to pick up while driving. It's a bit more complicated if the operator were to do that. So the driver will control the wheels and the claw as well as the lever so that they can also put it onto the backdrop. And the operator controls basically everything else. They control the drone, the actuators, the lift, the arm, and even the wrist. In terms of autonomous, so for autonomous, we use Roadrunner to just accurately path out our autos. It's been pretty consistent so far. We use this camera here, and we use OpenCV. And basically, we just take the two leftmost zones, and we look at the blue or the red values, depending on what side we are. And we just look at those two zones, and if those two have blue in it, if our marker is there, then we know that's in that. And if it's in none of them, then we know that it's in the right one, so we don't even need to check the right one. It just saves some time. Also, we made it so that our auto is completely configurable with our controller. So basically what we do is we combine all of our autos into one class, and we just, during initialization, we just press some buttons to kind of configure it on where we are, where we're parking, stuff like that.
Yeah, so I heard you mention that you're using Roadrunner. Are you using that with dead wheel odometry pods, or are you just using the drive velocity PID?
Yeah, so we're actually using 2 odometry pods. We didn't have access to a third one, so we're only using 2 for now, which means our heading is controlled by the Control Hub IMU. Yeah.
Have you had any issues with the Control Hub IMU? I've heard that some teams might see it skip or even just like break at some point. So are there any issues that you had with that this season?
So at the beginning, we were having a bit of trouble with the newer IMU. We didn't really know how to set that up, so we just kind of converted back to the older one. That was a lot more reliable, and we used that last year, so we knew that it was going to work. So yeah, we just used the old IMU from the years prior, and that one seems to be working pretty well.
Nice. Well, is there anything else that you guys would like to add before we end the interview?
It's been a community team effort. Yeah. And it really means a lot to see, the bot at this state. It requires work from everybody, right? I mean, without a builder, there's no bot, and without a coder, the bot doesn't run. Without outreach, we can't afford it. Without drivers, it doesn't do anything. So it really is a team effort.
Yeah, definitely. Well, thank you guys again so much for having this interview. And again, congratulations on your Finalist Alliance first pick position today. And hopefully we'll see you win some awards at the award ceremony. That's it for First Updates Now. I'm Yashis from First Updates Now, and I'm signing off.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.